today we're going to look at section 3.7. Our objective is I can graph systems of inequalities and indicate the solution set. So what we want to be able to do is show in a picture where the solution to a inequality in two variables is. So for example, 3x minus 2y is less than or equal to 8. This is example 1. So this is just a linear inequality. So step number 1, put in graphing form. That's step number 1. So we would subtract 3x from both sides, so we get negative 2y is less than or equal to negative 3x plus 8. Then we would divide both sides by negative 2. And since it's an inequality, remember to flip the inequality because you divided by a negative. Okay, now we have the equation in graphing form. Okay, step number 2 is now locate the line on a graph. Okay, so here's my coordinate plane. Here's my x-axis, here's my y-axis. So this tells me to go down to negative 4 is my y-intercept. Let me do this in red. And then it tells, the slope tells me from that to go up 3 over 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. All right. Now the next thing to do is determine if the line is included. So this one has an equal involved. So that means the line is included. So we do a solid line. If it was just greater than, we would do a dashed line or a dotted line indicating that that the points on the line are not included. But in this case, because we have this equal, the points on the line are included, so you make a solid line. Now, what I do is I focus on the y greater than or equal to the y-intercept. So I go to the y-intercept and I ask myself, where are the numbers bigger than negative 4? Going up the y-axis or going down? Well, they're obviously going up, so then I shade above the line. So this says every point in this shaded area will make this inequality true. So for instance, I could pick this point because the point 0, 0 is in that shaded area. And so I could check if I put 0 in for y and 0 in for x, do I get a true statement? 0 is greater than or equal to negative 4, so I know that I shaded the right side because I got a true statement there, right? So let's look at another linear inequality, example 2. In this case, I have x minus 3 is less than or equal to 0. So step number 1, put in graphing form. So x is less than or equal to 3, right? So step number 2 is locate the line on a graph. Right, so let's do our xy coordinate plane. So this is my x, this is my y. So I go to x equals 3. So I think the equation x equal 3. Right? So that's 1, 2, 3. X equals 3 is a vertical line. And because it's equal, the less than or equal, then I make a solid line. Okay, now I want all the x's less than 3. All the x's less than 3. So if I go this way, the x's are bigger than 3. If I go this way, the x's are less than 3. So this is the side I want to shade. Okay, and so we don't want this, okay, because it's everything to the left of that vertical line. All right, now when we do, well, let's do one more. Example 3. Okay, let's say I have 3x minus 2y is less than 6. Notice that there's no equal involved here, so that means when I do my line, it's going to be a dotted line. So step number 1, put in graphing form. Divide by -2. So y is less than 3/2 x minus 3. Okay, so next step, go to the graph. So here's my x-axis, here's my y-axis. I go down to -3, and then I go up 3, 1, 2, 3 over 2, up 3 over 2. Now, because there's no equal involved, I have to make a dashed or dotted line that indicates that the points on the line are not included. Okay, so the question is, where are the y's less than -3? So if I go here, if I go up the y-axis, those numbers are bigger than -3. So that tells me that I want to go the other direction, down the y-axis. Those ones are less than -3 because I have -4, -5, -6, etc. So that means I'm going to shade that side. And these are called half planes, because everything on this side of the line will make it true. And again, we can check that by just choosing any point. So let's say I choose this point. That's the point 1, 2, 3, 4, 0. So if I put 4 in for x and 0 in for y, I should get a true statement. Okay, and so this, I get 0 is less than 6 minus 3, or 0 is less than 3. That is a true statement, so I know I did it correctly. All right, now let's look at a system. Example 4. In a system, we just do each line. So let's see, we have 2x plus y is greater than 1, and x minus y is less than or equal to 3. So now we're going to put each equation in graphing form. So equation 1 in graphing form would be y greater than -2x plus 1. Equation 2 in graphing form, if I subtract x from both sides, I get -y is less than or equal to -x plus 3. Divide by -1. So I get y, and remember to flip this, is greater than or equal to x minus 3. Okay. Next, we go to the graph. And we just do everything for equation 1. So we graph it, go to +1, then the slope is down 2 over 1, or I could go up 2, left 1. Then I check to see, should it be a dotted or broken line? It should be broken because there's no equal involved. And then I ask myself, where are the y's greater than 1? If I go up the y-axis, do I have numbers bigger than 1? Yes. So I shade that side. All right. Now I go back, and on the same graph, I graph the other line. So that tells me to start out at -3. And then the slope is 1 over 1, so I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay? And there's an equal involved, so I make a solid line. And then I ask myself, where are the y's greater than or equal to -3? If I go up the y-axis, that's where the numbers are bigger than -3. But what I'm looking for is where the shading overlaps. So I would be shading above the line, but where it's going to overlap is from here over. So our solution, see, I would be shading here also, but the solution is all of this area where I see both the yellow and the green. So it would be all of this area in here. That is the actual solution to the system, which means that if I picked any point in that yellow and green area, so let's say I pick this point right here, which is the point over 2 up 1, then that should give me a true statement in both of the inequalities. So if I do equation 1, I would get 1 is greater than -2 times 2 plus 1. 1 is greater than -3. That is true. And if I put it in this one, 1 is greater than or equal to 2 minus 3. I get 1 is greater than -1. Those are both true. Okay, so I did the correct spot. All right, let's do another one. Example 5. What if I have x is less than 6, x plus y is greater than 4, and y is less than -1/2 x plus 4. So here I have 1, 2, 3 equations. So what I'm going to do is I'm going to graph all of those on the same coordinate plane and see where the shading intersects. Okay? So to graph equation 1, I'm going to think x equals 6. So x equals 6 is a vertical line that goes to the x-axis at 6. So 1, 2, 3, 4, 5, 6. Then it's supposed to be, it's less than 6, so there's no equal, so it's going to be a broken line. That's that line. So where are the x's less than 6? To the right or to the left? It's to the left. All these numbers, all these x values right here are less than 6. Okay, so there's equation or inequality 1. Now I do number 2. So I'm going to put this one in graphing form. So I'm going to subtract x from both sides. So if you inequality 2, I get y is greater than -x plus 4. So I go to graph that one. So go to +4, 1, 2, 3, 4. The slope is -1 over 1, so that's down 1 over 1. And there's no equal involved, so I do a broken line. Very important that you do the right kind of line. And then I go to my y-intercept, and I say I want all the y's greater than 4. So I go to here. If I go up the y-axis, those are the numbers greater than 4, so that means I'm going to shade this side. Okay? Now, I'm only going to shade right here because that's where I already have yellow, and that's where I'm looking for. Then I go to the third inequality, and that one's already in graphing form. So that one says to start out at positive 4. So we're starting out the same place, but the slope says down 1 over 2. Okay, and this is also going to be a broken or dotted line. And I want all the y's less than this 4. So if I go up this way, those y's are bigger than 4. If I go down this way, those y's are less than 4. So that's what I want. But then I look at where I already have shading. So it's going to be this triangular area right here. So that is the solution to that system of inequalities, is this triangular region where I have the yellow, the green, and the teal all together, right? Okay, so that's basically what you do. It's just graphing and shading and looking for where the shading is overlapping.